All right, hi. Today we're joined by Dr. Carolyn Rose. She's a professor at the Language Technologies Institute and the Human Computer Interaction Institute at the School of Computer Science at Carnegie Mellon University. Professor, would you please like to introduce yourself?
Sure. As Arusha said, I'm Carolyn, and I've been a professor at Carnegie Mellon since 2003. And I started out my career as an undergraduate in computer science at UC Irvine way back in the misty eons of time. I guess my first year was 88. So I've seen a lot of history in computer science, and I love being in the field and happy to be here today.
All right, thank you so much. Wow, so you've seen your fair share of how computer science has evolved through the dark ages, one might say. Yeah. So I'll dive straight into the questions. Um, would you like to sort of explain uh, so that we can take it from there, your research to someone who has a STEM background, say someone like me, who's got an undergraduate degree in STEM, versus explain it to someone who has a high school, who's a high school student.
Yeah. So let me start with how would I explain it to a high school student? What is it that I do? So when I was in high school, nobody even had computers at home yet. That was was that true? I guess they were very less powerful than they are now. Way less powerful than your phone. My first computer was a Commodore 64. They don't even exist anymore. They only had a maximum of 64K. That's probably, you've probably got files that are way bigger than that, single files, and that's all they, could have inside. And so I started out, I liked to try to make games, and I picked out a game that I used to play with my cousins, and I tried to implement that. The language that I implemented it in was called BASIC. I don't even know if anyone programs in that language anymore. You may not have even heard of that language. Things change all the time. But I think I just liked the idea that if you have a computer and you can write a program, that you can make your own toys and they don't cost anything because you already have the computer and you can have as many as you want.
Yeah, that's absolutely
So
true.
yeah. How I moved on from there is that I've always loved learning about things, and I wanted to be able to apply my ability to write computer programs to help people learn better. And so I've continued doing that. And I've been doing that my whole career. And there are lots of other things I do, but in the end, that's what I'm most excited about when I think about the possibility that something that I'm doing could give somebody the joy of learning.
Ah, yes. Thank you so much for that. That's a wonderful description, and I think that's something that I've deeply cherished about computer science. That has it makes things accessible to the public in a way that might not be sort of possible given the human resources that we have. Not everybody is trained to sort of, like you said, that the computer can essentially serve, like you can make your own toys by sort of programming the computer to do certain tasks. And I think that's where my next question comes from, is there's a real element, and I think that's what human computer interaction is all about, is that you're sort of you can use the computer as a proxy to teach students, like you said, that you're using computers to help people learn better. And and that really sort of joins in with what's happening around the world with respect to AI, is that, you know, there's this concept of socio-technical AI, in which you're sort of using AI to not replace exactly, but help mediate interactions between a teacher and a learner in a way that might not have been possible before. I mean, with computers, it already changed the landscape, but with the rise of AI, now that's going a completely different sort of a shift. So, you know, could you share your thoughts on that, like with respect to how your research defines this term of socio-technical AI, and how do you see it contributing to the development of um, human-centered learning experiences?
Yeah, I would say that what defines the idea of socio-technical AI is that we don't assume that the AI as a thing is solving the whole problem, that it's the answer. It's not the answer, it's a
Ah,
tool. And no matter how capable AI seems to be, that in the end, that's really all it is. And there's a lot, I think, to what seems to be the recent advances that's a little bit of an illusion. I do think that computers are very capable, but they've been very capable for a long time if you know how to use them well. I think they've become more usable recently, and probably the biggest change that's happened is the usability end, that now they're way more accessible. And so it seems like all of a sudden there's these capabilities that we never had before. But the truth is, it was just harder to use it before and less well popularized. Um, I'm not saying there haven't been advances in capability. I absolutely believe there has been due to scale. So and what I mean by that is that computers have become more powerful. Memory has gotten the capacity for memory. I told you, my first computer, 64K. Now there's like billions and billions
yeah.
of parameters, and that's just the model. And what about everything else that's part of a system that you're using? So because of that, of course, it's like if you had to write instructions to somebody on a 3x5 card versus giving them a whole manual, right? I
Yeah,
mean, obviously if you can give them the whole manual, they have more instructions, they can do
yeah,
more. You could think about it a little bit that way. So but I haven't really answered the question yet. The idea is that pushing the idea that accessibility is better now than it was before. There are lots of questions about what role the capabilities should play and which part humans should still do. And how do you fit those together, almost like a puzzle? And I think there's been kind of a stream of research since a couple years ago to really just try to put everything into one big model versus what if we plug that model into different places in a bigger set of instructions that we write or that have come from someplace else, and where do humans fit in? I do have one colleague who, every time I listen to him talk about robots, for example, I feel like it's like they set up the scenario where there doesn't need to be a human. It's all about that robot doing something. And I just don't like thinking about the world that way. I'm much more interested in how humans work, what humans are doing, especially what they're doing together, and how that can be supported.
absolutely. I completely agree on that. I completely second that point that um, uh, this particular thing, this particular aspect of humans interacting with robots, I think that needs to be laid in as at the foundation of when you're researching robotics, because at the end of the day, robots are supposed to, well, I mean, I think that's the whole point of robotics, is to be able to help human beings. So I think that I completely agree with you on that. That robots, robot interaction should lay the foundation of that. Um, so if you were to sort of look ahead, where do you think? So with respect to the thing that you said, that it's basically about reconfiguring the AI tools with respect to human computer interactions in the matrix of how humans and computers interact, and where to put the AI tools strategically in order to have them interact in the most optimal way possible, so that either robots or the AI is able to help the human in the most optimal way, or in either learning or doing some sort of task. What do you think, like, for the future, is in the broad scheme of things with respect to how humans and AI should interact? So I'm basically essentially asking how, according to you, in the near future, do you think humans and AI should interact to sort of further that goal that we just discussed?
Well, I think humans need to be more aware of the limitations of AI, because at the moment, I think there's a real overexpectation, and that doesn't really foster a productive synergy. And I think it just allows, on the one hand, for there to be some fear. And then on the other hand, a lot of hype and over expectation. We saw something like this probably, uh, you know, 15, 20 years ago when all of a sudden lots of other fields started to get the idea that artificial intelligence would have something to offer them, especially machine learning. And I think that there were some people on the more technical side who were happy to kind of sell the idea that there were aspects of work that people don't like to do, or that's expensive or time consuming or boring to do. And computers were going to be able to just do that for them. And they believed that, and for a long time. And uh, some good things came out of that, because I think because of the expectation, it drew more people into the field. It allowed for more interaction where you could observe what actually happened when people tried to do that. But in the end, I think there was kind of a disappointment that occurred, and people became wiser. But then, and now I feel like people are like, oh, but maybe now it's true. And so I'm like, oh no, not again. Uh, that being the case, I think if people in general were a bit wiser in their expectations of what the technology could do, they could think a lot more strategically about this question. Where are the best places to plug it in? Where is it safe to plug it in? Where is it going to be most reliable? Where is it going to have the most impact on the bottom line of what we do? We could have much more of a productive exchange. And I'd like to point out, and I think especially because this is aimed at high school students and college level students, there's a whole movement called AI for K-12 that's all about deciding what is it that everyone needs to know about AI at every stage in their education. Part of that is being led by Dave Touretzky, who's one of our computer science professors here at Carnegie Mellon. I think the work that they're doing is extremely important. They're working all over the country in the US. I know that there are similar efforts around the world in different places. I know that different efforts are talking to each other. You can see evidence of this in publications. And I think it's really important to answer these questions. And I actually love the way they've laid out the kinds of things. There's one particular area of all of that that I'm especially excited about, that's called representations and reasoning. What is it about the way information is stored inside of a computer that allows for behavior that looks like reasoning to occur? And if you kind of grapple with those ideas, though, you also don't believe that the computers are doing any kind of reasoning the way humans do, but they're able to do some things that have that kind of form, but then they're going to break down in certain places. And so if you kind of have this more scoped set of expectations from having grappled with those issues, I think that enables the kind of partnerships that will help us to think what is the best way that we can make use of AI.
So why would that be? Like, if you look at how computers are processing that information, you said that you're sort of amazed when you look at it and you sort of find out that you're not able to compute how the computer is able to do that. Like, what does that look like? Like, is it something that's completely emergent, and you seem to think like, and any scientist would seem to think that, okay, this was something completely unexpected, or is it something else?
I think a lot of people think of it that way. They think about the emergent behavior. They think the reason why, I think that or at least some of the argument that I hear, that's the reason why we might expect different behavior than we've ever seen now, is that people feel that they don't quite understand why we see the level of capability that we think that we see. And so they will explain it as, it's this emergent thing, that somehow in the complexity, there are things that can happen that are different from what we expect. I'm not going to say they're absolutely wrong. I don't happen to believe that. I think that you can have the appearance of emergent behavior from piecing together a lot of partially formed complex solutions. And the bigger the memory capacity, the more there may be those So I'm going to bring in a technical term, just so that you know that this is grounded in something that's real and that people have studied. In linguistics, at the University of Pennsylvania, they were famous for an idea called tree adjoining grammars. And what tree adjoining grammars were kind of partial solutions, derivations. So, like if in high school math, for example, you have these axioms, and then your teacher says, prove something. And then you start with, what are the assumptions I have? And then you kind of try to build to a solution by applying these axioms. Like, you can move things around in certain ways, you can group things in certain ways. And so you get what looks like a tree form. That's how you get from your assumptions down to where you were trying to get to in the proof. So language is like that too. We can have an idea, and there are language rules whereby you can get a derivation of a complex idea into its component language parts. And actually being able to compute what that is a difficult task. Computers can do it, but I'm going to say difficult because there are lots of rules, and it may take a long time to find the right way of putting them together. But if instead of having to do it from individual rules, there were already lots of sentences or ideas that you had these complete derivations, then you take pieces of derivation with like places where you can stick in, like a puzzle, other parts of derivations. Then with fewer pieces, you can get to a more complicated structure. And so I think what happens is, when there's a huge amount of memory capacity, it's possible to store a lot of complex partial solutions. So it still gives you the flexibility of applying to a new scenario, maybe that no one has ever seen before, but using knowledge that already came from other scenarios that are similar in some way. And so I think that with the huge capacity that large language models have, it's almost like the idea of tree adjoining grammar. And we're seeing what seem to be very complex derivations. But in the end, it's because we have these puzzle pieces that already do a lot. Because if we've seen a huge amount, there are lots of things in common at a level of complexity that we've never seen before. We've never been able to store that many because we only had the index card instead
Yeah.
of the set of manuals.
So sort of to fit, sort of to filter it down to like a more, simpler level. What you're saying is, because AI is essentially really competent at pattern recognition. It's able to recognize how all the puzzle pieces fit together. It's basically able to recognize the axioms or the rules by which those puzzle pieces fit together, and it's able to sort of not extract but deduce what kind of logic and what kind of sentences would fit a particular kind of logic, and it's able to then draw out that and give you something that it's gotten through just by brute force pattern recognition through the use of computational power.
Yeah. So, and I think you can get very far with that if you have a huge amount of memory. One thing to point out, though, is there are things that happen more frequently and things that happen less frequently in the world. So, and that pattern applies to lots of important areas of behavior. And so what ends up happening, at whatever scale we're able to store rules, we end up being able to cover the things that happen more frequently, but there's what we call a long tail. Lots of things that happen relatively infrequently. It's hard to distinguish between the important things that happen infrequently and the things that just happen and they were a fluke and you don't really need to remember them. So what ends up happening is that computers in general are very good at the things that happen very frequently and very bad at the things in the tail. It's just that if you have a huge amount of memory, you can have a much bigger set of things that happen frequently. It's like
Yeah.
you're zooming out, so then you see a different one of the same shape, but you're still stuck with the things that, so you're going to break down. The behavior breaks down when you get past it, where you can use the size of these kind of like chunked rules, and you're outside of the scope of what happens frequently. So and then there are other reasons also for limitations that don't have to do with capacity, but if you're focusing specifically on that, you already see where things are going to break down. And I'll tell you, I have PhD students who are working in lots of different areas of machine learning, like lots of different application areas. And we constantly see the same kind of breakdowns regardless of the area. And that's why I'm totally convinced that under the hood, this is the problem, because if you can crank up the scale, then there's a larger portion of things that happen frequently that even may look relatively complex, but eventually when it breaks down and I say, okay, let's do an error analysis, let's find out what are those cases, what's different about those cases, it almost always comes down to this, that there's an extent to which there's puzzle pieces coming together, and wherever that's going to work, those are the cases that are easy, and where that's not going to work, it breaks down.
So that's really interesting because I think so what you're essentially saying is that AI is good at interpolating, but it can't extrapolate. It can interpolate between those rules, but it won't be able to
Oh, it won't
extrapolate
come up
something.
with new rules. Well, okay,
Yeah.
so in terms of, so if you have a language for the extrapolation, it's not that it's not possible to do extrapolation, but that requires a lot of search there, because there are
How do you
lots of
mean?
possible extrapolations. If you just add all of them, then you essentially just are storing that tail, but then you don't have any principled way of navigating it, and it
Got
becomes
it.
very slow that way. So
Yeah.
it's not that they can't extrapolate, it's that it's difficult to extrapolate well, and it just creates the need for more brute force.
Mm.
So one of my
Yeah.
colleagues, I just want to point out, Jill Lehman, she's a good friend, a little more senior than me. She was a protege of many famous AI people who created the field. So and when I was working to put my idea for a PhD dissertation together, I read her dissertation. I still think of it. She was working on that extrapolation problem.
Was there some specific highlight that was it the same thing that you described, that it's not really good at sort of generalizing, and it basically you need to apply more brute force in all the different directions that it might be able to extrapolate in?
Yeah, I mean, essentially what she found was if you kind of give full rein to the extrapolation, it just becomes very slow and clunky, and you have to have some way of really focusing. If you extrapolate in a very narrow area, you might be able to get good adaptation to that area. But then, eventually, you have to scope it.
Yeah, yeah. So that's really interesting because that sort of brings us to the thing that, to this idea that everything that all kinds of advancements in AI can just be sort of, you can just brute force your way through it. And I think that's where this interdisciplinary approach becomes really uh, crucial in terms of sort of bringing in ideas from philosophy or cognitive psychology, in terms of shaping how humans infer things, because we're inferring things and we're trying to model machines on the basis of that inference, but we're not sufficiently capturing our own sort of mental processes into the machines. So could you talk about how, interdisciplinary insights from, cognitive psychology and, merging that with deep learning might help us proceed towards that sort of goal in a much faster and more efficient way?
Yeah. So I'm going to answer that in a kind of weird way, and then you can guide the conversation back to maybe another part of that big picture later, if this wasn't where you were heading. But the field of AI, back in the day when I was an undergrad and also beginning a PhD, there was this idea that because there was a lot of borrowing from philosophy, where where the roots of logic actually come from, and logical formalisms were big. People had a lot of disrespect towards anything in AI that seemed like a lookup table. That was like the biggest insult. Like that, well, that just reduces down to a lookup table. They wanted creativity in coming up with a small set of rules that covered a broad set of behavior. And people worked very hard on coming up with what would be that small set of rules. And I feel like now we are on the total other side. It's total lookup table. We just want a really big lookup table. And it's not, like I said, because of this idea that they're puzzle pieces and we're putting them together, we're not really wholesale looking for the entire solution as a lookup table, but there's a lot of lookup tableness that we're allowing now, and then being really excited about the results. But I, sometimes hear in my head, but that just reduces down to a lookup table. Somehow people are not insulted by that anymore. But I think that if we get back to our AI roots, and we think about, how can we have we would say perspicuous set of rules, really going for that elegance of a solution, compactness of a solution. We wouldn't need such huge models to get to where we are in terms of behavior. So I do think that there's a lot of work on hybrid approaches that are trying to bring in formalisms, but then I think that in some ways there can be an over reliance on the idea that if we just bring in the formalism, somehow that's going to solve it. But I think the idea is, it wasn't just that we had the formalisms, but we spent time thinking about what went into the formalism. And I just think,
Yeah.
and it's not that there's none of that, but I think if we invest more on that side and draw in our colleagues that work on those logical formalisms to be more core to the work that we're doing, we can probably find better ways of putting these worlds together.
So in that sense, I think a lot, the field might really benefit from bringing in, either people who are really adept at math and philosophy, because then they'll be able to sort of comment on how to break down those formalisms in a way that a computer can digest. That'd be
Yeah,
great.
and
Yeah.
I'll just point out, at Carnegie Mellon, we also have a philosophy department. It's very famous, and they're very computational. And really are up on these ideas of formalisms. And one thing I love about Carnegie Mellon is we're very big on interdisciplinary research. So there's a lot of exchange. Still, I think that there's a lot of space to go on conversations that will get us further in terms of bringing those worlds together. But just to kind of sell the environment, it's one of the reasons why I love coming to work every day.
Absolutely. No, I completely agree with that. Yeah. So I'm just quickly browsing through my other questions to sort of think about what I'd like to discuss next. One of the things is, because we did talk about philosophy, you said that in your work you've mentioned that abstraction and decomposition, and like you said, representation and reasoning, they are significant challenges for large language models. And this particular idea, I'm sorry for dragging it out for a bit, but I think this is a very important concept where you're sort of trying to, math in the language of mathematics, or in a language that's easily digestible for a computer. You're trying to extrude those concepts from philosophy. So how are you currently approaching these issues with respect to abstraction and decomposition, and what progress do you see on the horizon in your own group, not just with respect to the broader sort of you know teams of researchers that have been working on this?
Well, so one thing that we're doing is we're participating in this ARC challenge. You might have heard of that. What I like about that is the idea that the data set for this competition really squarely focuses in a way that gets you right at the heart of the matter. So, and I don't think that there's a trivial solution for sure. I've been working with a group of students to do experiments in that space, also to keep up with what other teams have been exploring. And I feel like we still haven't made significant headway, but at least we're really in a place where we can grapple with those problems. And one thing I see is that a lot of techniques that work on other kinds of benchmarks, they may have a huge impact on the capabilities on a natural data set. When they're applied to this data set that's carefully curated, they just don't have nearly the impact. And I think that that just highlights again what I was saying earlier, that natural data sets have this property that there are things that happen very frequently. And in that
Yeah.
space, a lot of the techniques that we develop give us, expanded capabilities, but they have very little impact on that long tail. But then you don't notice that because those are small numbers and this is a big number. So one thing is just like beating our heads against the actual problem, but I think that we have a lot of ideas about how we might be able to explore in that space. So we just were talking about how it is that extrapolation is hard. But you might be able to learn to extrapolate by watching humans who are really good at, you know, exploring a bit. How can we, be spontaneous and try stuff. But we have some intuition as humans, that we can make a lot of analogies that allow us to extrapolate better. And I mentioned also one of the goals of the research is to figure out what is the role of the AI versus the role of the human in all of that. And so we would like to be able to learn new decompositions by watching humans and then incorporating those into models. So in the work that I do in collaborative software development, we have environments in which people work together on software problems with LLM agents as support. And in that environment, we have all of the infrastructure that allows us to study this. And so we're pushing forward with that. There's a long way to go, but that is an area where we're doing work. So what does that work end up looking like on a day-to-day level? Well, similar to how I admire the work that they did to put together this ARC Challenge data set, we design collaborative software development problems that give the opportunity to observe humans doing this work. And so some of the collaborative software development studies that we do are in classrooms where students are working together on problems for their class. But we also look for other opportunities and think in terms of what kind of problems might be particularly conducive.
So one of the things that I've been able to sort of extract from what you've just said is that because, these natural data sets converge frequently onto like a smaller pool of data, which is probably, dictated by some law that's governing that particular data set. Say, for example, if you were looking at some kind of natural data set of, accelerometers that are, that have been attached to, airplanes that take off and land, and given that you sort of draw out the mechanics, and you'll just find that okay, the regardless of what the laws, what numbers you can actually fit into the laws of physics, at the end of the day, the data is only giving us a certain range of numbers. And because of that, we're not able to do a good job at exploring because the data set is just limited to what we've actually explored. So one of the things that I was thinking of then, is it, I mean, this is more of a philosophical question, but is it that because we're not allowing the robot to actually explore, like literally explore its physical surroundings, that we won't ever actually be able to achieve something that generalizes or extrapolates that well, because it will only ever operate on the data set that really converges. And regardless of what we do, we'll always only be able to give it data set that we've collected over with specific equipment, which will always almost which is guaranteed to converge, depending on the kind of equipment that we use.
Well, so I think I wouldn't put it so starkly. So I think there are different policies that guide the extent to which we allow, and I'm going to go beyond physical robots to
Of
just
course.
agents or even just models in general. There's this idea of exploitation versus exploration.
Yes.
And so within that space, we give some time to one, some time to another. If we have a lot of knowledge already, then we can explore more effectively, but we'll explore better in a space that's closer to what we've seen. We'll explore less effectively in spaces that are not what we've seen. But if we never stray into those spaces, we also don't expand the boundaries of what it is that we know. And so in adjusting those strategies, how far out do we go? How much time do we spend doing that exploration versus getting mileage out of what it is that we already know? That's going to change what we end up knowing, but also what we are able to accomplish during the time while we're still learning. Because as I pointed out, if if the model explores in a space that it doesn't know well, it's less likely that what it's doing while it's exploring is actually paying off in terms of your task at that time. And yet you're investing in the future because you're getting to know the landscape. So it's more like short term and long term gain. And
Yeah.
a lot of what's going to end up working is also something about the landscape that you don't know until you explore it, right? So then but then within certain kinds of problem spaces, they have a lot in common, So let's say that you are learning how to. It's a robot that. And I apologize to my robot colleagues because I'm not a robot person, so they may say, "Oh, it doesn't work that way. You're wrong." It's an analogy. I'm just giving you an analogy. But let's say you're working on robots that are going to be little helper robots in grocery stores. From one grocery store to another, they're going to have a lot in common. They will be different. They might, organize their aisles a bit differently. However, if they're using the same strategy that, they put things next to each other because people buy them together, then there will naturally be pressure towards similar organizations across grocery stores. So if you've had a robot and it's, maybe you're sharing software between robots and they've only been ever working in grocery stores, then there's probably a lot that they learn about a policy for how you learn in a new grocery store. But now if you put them in a different kind of store, maybe like a department store instead, then some of what they knew will be a good policy, but there might be things that work differently because department stores have departments and departments have their own internal organization. And now it has to kind of understand that there isn't sort of a uniform way in which like all the aisles are organized, so it has to learn something new. So that all comes down to the idea of strategy and how generalizable is the strategy kind of depends on the scope of where you're putting the thing that's exploring and how it can borrow from knowledge that it got from another place. So it becomes a really big problem. I guess the bottom line answer there is it's not so cut and dried. And we know that there's a lot to balancing the exploration and the exploitation. A lot of work has been done in that space. There's a lot that's known, but I think that there's still work to be done. And sometimes it becomes a different game. Like maybe we've in the field been working in under certain constraints. Some of what really pushes research forward is identifying what are the constraints that define the research as it's been done so far. What does that allow us to generalize to? But where are those areas where we don't have enough wisdom yet, where research still needs to be done?
How does because you've talked about that, how does involving multimodal data sets sort of help or obstruct in that particular search?
Yeah, that's a good question. So um, part of it is that as humans, we're very aware of our surroundings. Our surroundings are giving us data in lots of different channels. And some of what allows humans to perform at the level that they do is how we manage, how we're taking in those different channels and integrating them together, or sometimes blocking some of them out. So there's been exciting work in the area of multimodal. So some of my robot colleagues are doing work in that area, but other colleagues as well are working on multimodal things about communication because as like, see, I talk with my hands. There's a lot of nonverbal communication that goes on as well. And if you ignore it, then there's important things about what's happening in the interaction that will be lost. Um, so, so, so the obvious, what seems obvious is the answer is absolutely we should just take in all these different channels of data and synchronize them. But of course, that creates a lot more complexity. And so, whether or not it comes out as an advantage depends on the task. And so, there are uh, so you can always come up with examples of we never would have gotten blah 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 right if we hadn't put all these pieces together. But if that doesn't happen very often, then you might be in a situation where you actually don't end up seeing that much benefit. um, Probably if you look out to the literature on multimodal, you'll see that the focus is on the places where the impact can be greatest, and that's the right thing to do. And I do think that there's a lot that can be gained from multimodal. But I also wouldn't necessarily assume that the best solution for everything is that you always use all the data that's available. Because if it's kind of overkill for the thing that you're trying to accomplish, then you might just require a lot more machinery than you're really getting mileage out of.
Yeah, no, that's yeah. I
It's kind
mean,
of like that
it,
song "Nobody Walks in LA."
oh God,
You should
sorry, I haven't heard that
really,
one.
if you're really just trying to get to
Oh
the point,
yeah, oh
maybe
yeah,
don't
yeah,
get in
yeah.
the
Yes, I got the reference. Yes, yes, yes. Like everyone drives around in LA, they don't walk. That's the point, is it? Yeah, yeah.
It was
Okay, so,
popular maybe when I was in maybe high school or college. I don't remember now.
I see, I see. Yeah, no, that makes sense. Yeah, yeah. It's an overkill in the sense that you're just using a lot more resources than you're supposed to, or that would do you good. That's really fascinating. So, you know, I've actually run out of questions on this particular topic to ask, so I'll change the gears a bit. Um, so in your work, you've explored the effectiveness of LLM guardrails, with respect to how the public perceives AI systems, and this is, I suppose, uh, you know, a bit more towards safety of how AI tools are used by the public. So, what have you discovered about how the public perceives AI systems and how these insights would inform the design of safer safer tools for them to engage with?
Yeah, well, that's a big question.
Yeah,
And there's also
it is.
the question of what even is a guardrail per se. And I will say that so I guess I started being interested in this question because I felt that there is a dangerous extent to which sometimes people who don't know as much about the technology overtrust it on issues that I would just never trust a computer on. And so it's important, I think, to go back to what we used to think of as information literacy. That was a big thing back when search engines were becoming popularized. And I feel like that area has, maybe I'm just not aware of the work that's going on. I feel like people aren't talking about that enough. And then all of a sudden, when ChatGPT and other LLMs became available, people started to turn to them instead of search engines. Now there's much more integration between the two. But for a while, it was a choice. And I felt like it was dangerous to get away from where it was more obvious what the sources were. There were strategies that were developed on how to be kind of careful in an information space. And I felt like there was a little bit of opacity when it came to getting information out of an LLM. And it's such a polished presentation that it feels like you could just trust it. And maybe that's a bad idea. I think that now, and everyone can come up with their favorite, stories about where that's gone wrong. So maybe people are a little bit more wise now. I've noticed recently, and I'm very excited about this, that even on ChatGPT, you ask a question and you can click to get the sources. And there's a
Yeah.
lot of work on how you can tie sources to the information that you get back. And I think that addresses a lot of the concern that I had in the past. I think there's still a lot of work to be done in that space. I've got colleagues at Carnegie Mellon working directly on those approaches, and I'm really glad that they're doing that work. I think it's still extremely important. I think there's still work to be done, but I feel like we have made some headway on that front. And now, actually, one of the exciting pieces of work that some of my students are involved in is, like you said, working on the perception of these guardrails. So there's the safety aspect. Are there questions that people should not be able to ask LLMs and they shouldn't get the information? But there's also kind of, how should that be communicated back to people, and how does that affect the level of frustration, or the extent to which people will just game it, or whether people will lose faith and then not actually get the benefit from their interaction with LLMs that they should have. So again, I think important questions, and that's more on the human computer interaction side. How should that interaction play out so that people get the maximum benefit in a safe kind of a way? And I will say, I think that it would be naive not to think that there are people who try to use technology. I'm not going to say, I'm not pointing fingers at any particular organization, but I'm also not naive that in the world there are people who try to deceive people and can use any technology that way. No matter what you build, no matter what you do, it can be used for good, or it can be used in less productive ways. And so we do need to be wise. And I guess the bottom line there is, I think there's a lot of work to be done still on the very technical side. How can we make it more apparent where the information is coming from? And on the human computer interaction side, how should those interactions play out? How do we place the role in the interaction between the human and the machine so that it's, happening productively, not in a kind of antagonistic, like gamey sort of way, but we're just facilitating the flow of information in productive ways that are helpful.
So, what are some kinds of ways that LLMs might be used antagonistically?
Well, I think there are two sides to that. And I don't want to sound like, a conspiracy theory type person. I'm really, not like that, but there are people who try to get information from LLMs that they shouldn't be asking for. Like, can we break it so that it gives away private information that might be lurking in there? So, and I think it's really important to understand that there are people who try to get access to private information that they shouldn't. And it's really important to try to prevent that from happening. And I've been part of research, for example, in the medical space, where there's a huge concern about that for very many reasons. And that's why I think there's also been work in cybersecurity on how to guard against that. But then there will always be ways that people are afraid things can be broken, and that private information will be leaked and it will have some harmful effect on somebody, and they don't want to risk that. So there's that side. We know that there are those out there who are trying to get past any kind of boundary that you might place on that information, and that they stand something to gain. from that. Just like if you work for an organization, like a government organization, you have to take these training classes every year where you learn not to let people manipulate you into letting them in a building that they shouldn't be in or whatever. So we know that there are those people. It's not that, we're paranoid that everyone is like that, but there are people who try to get in where they shouldn't be. So on the other side of that, there's a worry that people could manipulate the information that's coming from the LLM in order to promote misinformation, and that it will be taken as authoritative because there's this belief that because there's so much data behind what these models are doing, that somehow that if somebody was really good at manipulating the set of training data or the decoding algorithms that are prioritizing what is coming out and being given to people, that could be used for harm as well. So there's no doubt in my mind that that there are people who could be doing that, because on the positive side, there's been a lot of work on trying to keep it clean, for example, or keep it not, away from harmful biases, from mistreating people. Whatever technique can be used to manipulate behavior for good can be turned around on its ear and used in a negative way as well. And so there's worry about how can people protect themselves then? How would you know? So I think, and again, I think that circles back around to the information literacy questions, that we have to be wise as people and not just naively take whatever it is that we get. But, is that really different from teaching your kids not to get into a stranger's car or take candy from some adult that you don't know? So maybe I think we need to work on all fronts to make the world a safe place. And I hope that people will continue to actively work on those issues. And maybe just like as a side comment, so you've asked a lot about lots of areas that that my group is involved in, but these are all really big problems that no one person could ever solve. We're just chipping away. So my group focuses in a lot of areas because I like to make connections. I'm a boundary spanner, and I encourage a lot of diverse directions within my group. Because I think that in doing that, we're aware of a lot of what's going on. We can contribute to those things, and we can have this kind of zoomed out view of where these different problems fit. But then what you'll notice is that what that means is I can't claim that I, have solved any of these big problems on my own. I'm just part of a community, a worldwide community of researchers all chipping away at these things together. And research really is about being part of a community. And actually, I love that about it. It's really a big sort of worldwide conversation.
Right, that's really so you gave like a really holistic view of what how these kinds of technologies might actually um threaten us as a society as a whole. And because you did talk about sort of telling your kids to not do certain things, which might be akin to telling them to don't take candy from strangers, and that's a bit it's a big it's not a happy thought exactly when you have to think of it. It's kind of scary. So I mean, moving on to things that AI can sort of help, looking ahead, where would you see the most exciting opportunities for AI to make a positive impact when it comes to kids and sort of collaborative learning, over the next decade? I mean, I'm switching gears again, I know, but it got a little bit, yeah,
Okay, steering away from the scary.
yeah,
And
yeah,
also
exactly.
so something that I am going to be participating in soon, a workshop that's taking place at the University of Pennsylvania called Create AI. And it's about opportunities for kids to learn about artificial intelligence through doing projects where they actually experience using it to build an experience, but then also being part of that experience. And again, I think that this comes back to this idea: what do people need to all know about AI in order to even function in this world, as it's continuing to absorb a lot of the new tools. And so I'm excited about being part of this workshop and finding out more. We're working on our own contribution to that workshop, where so this is just a kind of fun thing. If you look at my website, you'll see on my personal page, I'm really into weaving, and shaft weaving, in fact, has a lot of connections with machine learning. Even just in how shaft looms are built, there's actually a kind of internal matrix factorization that's part of how they're set up, which is, I think, super cool. So I think that it's possible then, as kids might be involved in a process of designing a textile that can be woven, in actually grappling with some of these really deep representation questions, because it's so physical how you see the matrix multiplication in action, and how it produces a cloth, and where those patterns actually come from, and which parts you have near-term control over, and which ones actually require spending hours and hours getting those threads exactly through the little petals that they should be in, and um, so what we want to do is actually teach a little bit about that math and the design, but then get kids working in groups on design with LLM agents supporting the design, so that they have the opportunity to see where in that process they're able to actually give good advice versus where they are not able to see all of the layers of structure and abstraction that a human can build into that representation, but that might go beyond the capability of the LLM agent to see. And
Yeah.
so then I think there are lots of different levels at which these questions actually come into that scenario. While it's also fun because
Yeah.
you design something pretty in the end.
Yeah. So, you know, adding on to that, like as a question, because you said that, you really have to be observant about with respect to where the LLM would or the AI agent might be able to help in collaborative learning. So, you know, given that your work has shown positive effects on classroom outcomes, are there any particular aspects of those interventions that you believe have been the most effective in terms of, in an educational setting?
I mean, I think that there's a theme across all of the work that we've done for decades. And I think it's well known in the science of human learning that there's an important role for reflection, that people have to stop and think and apply the ideas, maybe axioms, as they're hearing about them, in order to really, it's like building up your fine motor skills by building stuff, right?
Yeah.
So you're working those like fingers in your brain in some sense. And so there are lots of ways of introducing those kind of speed bumps into the learning process, so people stop, they challenge each other to do that reflection, they stop and they see the opportunity to do the reflection, maybe some external piece of information or some external question comes in, causes them to stop and reflect. But really it's that experience of stopping and reflecting, asking questions, thinking like, did that make sense? That's the experience that we want students to have. There are lots of ways of introducing that experience. That's what causes people to learn. I think some people thought in the beginning that all of a sudden LLMs were going to totally transform how education happens. I think that they give us the ability to retrieve lots of information, then, but what we still have to do is create that experience. So we have a recent journal article that came out where we used LLM agents to prompt for reflection in a collaborative software development activity. But actually, it's a little bit of a sobering message in the end, which I have to say that the journal editors pushed back on a little, and I would have thought that they would have been receptive to it. The truth is that there was a very narrow part of the experience that the students had where the capabilities that LLMs bring in was able to contribute, and it met a specific need for a specific subset of students in a way that would have been hard to accomplish without the kind of capabilities that LMs have too. Find details in a conversation as it's happening, extract them, and recombine them into a kind of form that might be a scaffold. That would have been hard to do without LLMs, but it really only played one little small role for a particular subpopulation. But you can fold it into a larger intervention, most of which we could have done just fine, 10 years ago. But now we can meet the needs of that very specific subpopulation at a particular time in the intervention better. Now, you might say, oh, that's not very exciting because you haven't changed the world with an LLM. But I think the truth is they're not going to just change everything. They're not taking over. They're not designing all of our curriculums for us. There's still really a role for understanding very much what is it that you want students to learn during this hour? What is it that that they need to do actively during that in order to come to the other side having gotten the appropriate exercise that they need to have, and where in that is the best place that we can introduce these LLMs. That's more effort and more thought than people want to believe they have to put in. They really would love to believe that, oh, we have this great thing and it's going to do it for us, but the truth is it's not going to do that for us. So yeah.
Absolutely. So following on that, let's say, hypothetical scenario that each student, each kid has access to an LLM. How would you sort of go about redesigning the curriculum that they're sort of facing to be able to maximize learning, given that they have access to this particular thing? I mean, just an example, not really like a formula, but more like something that you think would definitely work given where we are at right now, not even in the future, but like right now, in today's day and age.
That again, I would make an analogy between LLMs and search engines. So the more the life on the web has built out, the more information sources are digital. The more opportunity there is for people to teach themselves stuff that they want to learn. And I actually think that that's the biggest opportunity. That now, actually, even I will say, I get a lot of recommendations from ChatGPT on where I can find good resources to teach myself stuff. Now, in order to actually be able to teach yourself stuff, there are lots of skills that you need to have. You need to set an appropriate learning goal for yourself. You need to set aside time to get to the material, sit and listen, actually practice, apply it to something. These come under the heading of self-regulated learning skills. So there's the kind of self-regulated learning that's about individual learning, and then socially shared regulation of learning, which is more about how groups of people can learn together. We can make use of the resources that are out there in the world if we have good learning to learn skills, I guess is a good sort of overarching idea. And so you might remember, maybe 15 years ago, the big thing was the massive open online courses, and people thought that was going to revolutionize learning. And I don't think that it ended up having the impact on learning worldwide that that the hype would have said at the time. But one thing I noticed was there was a lot more research at that time on self-regulated learning and socially shared regulation of learning. That people recognized that in order to take advantage of these resources, you actually had to be good at creating an opportunity for yourself to learn, setting reasonable goals, et cetera, et cetera. I think it's the same. I think now what we need to do is think about these ways that humans interact with this resource to get at stuff that they can teach themselves. I think when you go to school and you are part of a curriculum, there's still a lot that's guiding that's people outside of you telling you, we already know you need to learn these things and you still need to learn these things. And we already have good ways of teaching them. And we're not going to throw that away. We can maybe make it a little bit better, but we're not going to throw it away. That would be really unwise. But I do think that we all benefit from having the opportunity to go out to resources that are available and teach ourselves things. And that's just been increasingly becoming a thing. One of the ways I got into weaving was I actually wanted to have the experience of learning something on my own that I never talked to another human being about, but I just learned it all from web resources. And because I wanted to kind of understand more that experience, and I thought it would give me good ideas for my research, and then I ended up loving weaving. But I do think that there's a lot out there that we can learn, and so the resources for helping us access information are getting better, but we still need to have those skills of using them. And that's where I think the impact is going to come. It's the learning that we do on our own. It's the lifelong learning. It's the learning outside of the classroom.
So thank you so much for that, because it brings me to the point that, and I'm putting this both as a comment and a question and an extension to what you were talking about. For me personally, I feel that when you're growing up as a student, not just as a child, but when your mental faculties are maturing with respect to any given field and you're learning new things, one of the things that I found to be of utmost importance, because you talked about resources, is finding the right resource at the right time. Like when you're trying to ask a particular question, which is like sort of irritating you, it's almost like an itch in your mind. Like, why is this not happening? And you don't have that resource, and you do not know that it exists. So those two things combined, that you don't have access to that resource because you don't know that it exists, and so that's one really big thing. And obviously, I do realize that we're running out of time. So I just wrap up one more sort of big question in, because I do think that these two things are complementary in nature. Is that when you're, because you have worked on designing AI to assist teamwork, right? What improvements can, with respect to improvements being observed in team dynamics and finding the right resources at the right time with respect to the entire team, could you talk more about that? Like, so my question is, I'm sorry, I sort of mixed up the two things whilst I was aiming to sort of compress it. Question A is that, how can we sort of model or design the technologies that we currently have, sort of shape it in the direction that it's able to assist students to finding the right resources at the right times, and also helping teamwork to sort of probe them. Like, let's say a team is having a discussion of sorts, and if you were to just give them a spark, like an initial value of sorts, that might just cascade the discussion into something that might bloom and help them discover things that they otherwise might not have been able to as a team. Uh, what is the question clearer than before? I'm sorry for mixing it up.
I think I hear where you're going with that. I think what that connects to in my research is, how do we actually support the development of interdisciplinary collaboration skills, and how do we help those interdisciplinary collaborations to happen well? It's a very hard problem. I think that the idea is that when people come together to solve a problem, they each have their own expertise. It doesn't always happen, though, that they have the opportunity to contribute that expertise when they're working in a group. For lots of reasons that have nothing to do with what we understand, it can be more social. Like, you may just not respect people from a particular field and just disregard what they have to say, even if, in fact, what they have to say is very valuable and needed. So, there can also be the idea that there are pressures, external pressures, that keep us from listening to each other and working well together, because, say, the reward structure that I'm in says I have to get this done by this date, or I'm not going to get my what I need to get out of it. But meanwhile, you're not going to be able to because of what you need to be able to do for your own thing. I'm asking you to do something for me that isn't good for you. So how do we work that out? So I think there are lots of ways in which there's a social side, a political side to working together, that there's an interplay between that and the flow of information and the ability to solve problems well together. So that's the problem that we're up against. But what do we do about it? Part of it is about building up skills, very analogous to these learning to learn skills. How do we teach people to anticipate that these are the kinds of problems that happen, to notice them when they're starting to happen, and to plan how they're going to deal with it? And so there might be scaffolding that we can offer that help people to be aware of those processes, to maybe notice the signs, to be able to have ideas for how they might address those things. So I think that's an extremely important direction. I think that there's a lot of research that's been done on what we might want to introduce and how we can build those experiences. But there's also a challenge. How do you actually create that experience in a classroom when you have limited time and where people are still gaining their expertise and they're also not in those kind of adult reward structures that pull people in strongly in different directions? We're really working on trying to address those. I think again, these are hard problems. I think I've mentioned a lot of hard problems in this conversation that make it seem like I'm just not doing anything because it's just all hard problems. I like thinking about hard problems. I'm not really at my stage into like, let's do the easy thing that's going to get us lots of papers quickly. I want to really get at those meaty problems, but that's still a challenge. We're thinking about how can we do that, or where is the appropriate place to teach people these skills. One thing I'm totally convinced about is I don't believe the argument that just putting kids in groups to learn is going to give them the skills to be good collaborators as adults. I think we really need to think intentionally about how can we use those experiences so that students learn those skills. We also need ways of being able to measure whether they have them, where are the weaknesses, and what do they need to shore up on. I think that where technology comes into that is we definitely have been working in the field of machine learning on lots of sensing technologies. And we can sense things like people are getting stressed out. You know, people are not being nice to each other. This is not going well. We made progress on that, and that's part of what we need. But I think there are also questions that go beyond that, so that we can use that well, so that it's not just that we can do this thing, but it's helping us get to where we need to go.
So the two things that really are that I'm getting at, from what you've just said, one is to be able to figure out the social matrix that's deeply individualistic, like the way that I perceive the world is completely different than a different student, and the way that we interact is completely dependent on how those social matrices interact with each other. And for the AI to be able to figure that is itself a Herculean task. And the other one is, obviously to be able to understand, the deeply individual problem-solving skills for that particular student. So, just to wrap up, I'm really grateful that you came to the podcast. To wrap up, what advice would you give to someone like me, as well as a high school student, about how to approach technology so that we may learn better in our student lives, and even otherwise?
Yeah, I would say I encourage people at the beginning of their PhD to look very broadly. Try to zoom way out first to identify where is that one place on the landscape where you want to go deep. Then when you find it, go super deep. Have people around you who are doing the other things, but you really can't learn everything. You can't be a jack of all trades always.
Yeah,
It's safe for it to be broad later in your career. You're going to have to be very narrow during your PhD, but start out in the very beginning, zoomed way out, read voraciously, and then make a decision about where you want to go deep, but then go deep. That would be my advice.
Yes.
Because sometimes students try to do everything. You can't do everything. Then another mistake is I have blinders on from the beginning. I don't do either of those things. Zoom out first and then zoom in.
All right, thank you. How about thank you so much. This really, I think I really appreciate that advice. What would you say to a high schooler?
Oh, what would I say to a high schooler? Sorry that I sort of zoomed into PhD. Um, as a high schooler, I think you should appreciate the fact that at this time in your life, you can just explore, and you don't think you have a lot of time, but you have more time now than you will ever have at any other time in your life, and you can invest in your hobbies now. I would make use of the time. Like, don't stress yourself out. Don't feel like you have to be, like get a Nobel Prize in high school. You don't have to do any of that. But at the same time, I would say realize when you come home from school, get your homework done, and then you've got hours to invest in something that you're interested in. Find out what's exciting and interesting to you and really take the time to sink your teeth in. And yeah, I sometimes wish, I had those hours. So yeah, take advantage of it.
Professor Carolyn Rose, thank you so much. It's been an honor. Thank you so much for coming on the podcast and sharing your completely, uh, priceless advice on and your research and everything. Thank you so much. So I'll just stop the recording now. Thank you.